Okay, so today I want to do a little refresher about doing math with units. Let's look at number 8 on the math pre-assessment retake, which is this. The equation D is equal to m over v describes the relationship between density, which is D, mass, which is m, and volume, which is v. Solve for v, so we were going to solve for this, if m, the mass, is 28 grams and the density D is 7 grams per centimeter cubed. And then the last part says, importantly, report your answer with units. Now, most of us got the correct number value here, which is 4. To get this, we first rearrange the equation, just like Mrs. Karpovich did in her explanation. So we've got D is equal to mv. We're going to multiply this side by v, because now we've got v over v, and they cancel. Since we did that on the right side, we have to do it on the left side. And now we have v times d is equal to m. Remember, we're solving for v, so we need to get v by itself. So we're going to divide both sides by d. This is pretty familiar to you guys from your Algebra 2, I know that. And now we've got v is equal to m over d. What does this mean? This means that if we know what the mass of an object is, and we know what the density of that object is, we can find the volume by dividing those other two quantities. And so we go back to our original problem. We have the mass, we have the density, and so we go ahead and divide them. We get 28 grams divided by 7 grams per centimeter cubed. Awesome. So if we take 28 and we divide it by 7, we get 4. And that's the numerical part of the answer. But then we get to the units part. And so we have 4 what? So we're left with this. And what a lot of us did was we said we've got 4 grams over grams per centimeter cubed. Oh, look, we've got grams over grams. And so we're going to cancel these guys out. And we'll be left with something like 4 over centimeters cubed. Or some of you said that that didn't really make any sense, and so you just left the gram in, and we continued to have grams per centimeter cubed. And I totally see why you would do that, but it's not the right answer. So in order to talk through the right answer, I first want to take a step back and have you notice that if you look at this part of your answer, it's basically a complex fraction. So you remember this from like way back, probably 4th, 5th grade math, dealing with complex fractions. Let's say we have 1/2 divided by 1/4. Yeah, you remember those. It's kind of hard to see immediately how to do that. What you do, if you remember, is you take that bottom fraction, flip it on its end, and you multiply the first fraction by the reciprocal of the second fraction. So now you have 1 times 4 is 4 over 2 times 1 is 2. And so you do that math out and you get 2. Okay, so that's the same kind of math that we're going to be doing with our units so that we can get the right units. So now, instead of having 1/2 divided by 1/4 or anything like that, what we've got is grams divided by grams over centimeters cubed. So let's take this grams per centimeter cubed as our bottom fraction. Just like before, we're going to take that, flip it upside down. We're going to get centimeters cubed over grams. And now, what do? Remember, if you have a number that does not have anything in the denominator for a fraction, there's basically an implied 1 under there. So we're going to now multiply g over 1 times centimeters cubed over grams. And just like most of you guys said, we can cancel out those 2 grams. That's not a problem. And if we multiply across, now we've got centimeters cubed over 1, which is just centimeters cubed. And these are your correct units. So your final answer ends up being 4 centimeters cubed. Great. Now, we're going to go over this in a lot more detail later on in our measurements unit. But I just have a couple of tips that I want to give you right now, because units are a huge part of chemistry and of this class, and just to give you a little bit of a jump start on it. First of all, always think about whether your units make sense, because they should. So a gram measures how much mass is in an object, whereas a cubic centimeter, like we have here, measures how much space something takes up. So it doesn't make any sense to have a volume, which is what we're solving for here, reported as anything with grams. That would be like somebody asking you how big your car is, and you tell them, well, it weighs 1,500 pounds. It's just not the right kind of answer that they're looking for. It's not a wrong answer, but it's a wrong answer to the question they're asking. So always ask yourself if the units make sense. Second, remember that the units apply to your whole answer. Including any variables that might appear in your solution. So let's look at our original problem again and pretend that instead of our mass being 28 grams, our mass was 28 x grams, where x is just some number. You would solve the problem exactly the same way as we did up here. So you would end up with a volume equal to 28x grams over 7 grams per centimeter cubed. This number would be the same, still 4. And these units would be the same, just like we talked about here. And you would end up with centimeters cubed. Now, what do we do with this x? What a lot of you guys did in number 7 was you put the x at the end. And you said something like 4 centimeters cubed x. And you don't do that. No. Instead, what you do is you take any variables you have and you put them next to your number before your units. I didn't take off any points for this on the original test on number 7, but I do want you guys to be aware that this is the right way to put it, because whatever this x is, when you solve for it, if you end up solving for it, it will also be in centimeters cubed. So that's it for now, guys. I hope you know a little bit more about units, or at least remember more than you did before. Thanks for listening.